Electroplating is done to make the object more durable and more valuable. For electroplating, the object that has to be electroplated should be at the cathode. And the material that is used for electroplating is at the anode. The electrolyte is a salt solution of the anodic material. For example, if we're plating an object with silver, this is silver, this is the object. The electrolyte would be silver sulfate. Now silver would form ions at the anode, so the anode equation will be silver plus 1 plus electron. These silver ions will move towards the cathode, and over there they will form atoms. These atoms will coat the material. So at the cathode, silver ions are reduced to silver atoms. Galvanizing is coating a material with zinc. This makes the material more durable and long lasting because zinc reacts preferentially to the material, leaving it unreacted. Sacrificial protection is usually done for iron. Ship bodies or underground pipes made of iron are connected to a magnesium or zinc block. Now magnesium and zinc, being more reactive than iron, react preferentially to iron. Iron is left unreacted and does not corrode, whereas magnesium and zinc react with oxygen to form oxides. Extraction of aluminium. Aluminium is extracted using electrolysis. The ore of aluminium is called bauxite, and that is Al2O3. It is pink in color. The main impurity in bauxite is iron 3 oxide. Now to remove iron 3 oxide from bauxite, the bauxite ore is broken into small pieces and reacted with sodium hydroxide. Now bauxite has aluminium oxide and iron oxide. When NaOH is added, NaOH does not react with Fe2O3 because both Fe2O3 and NaOH are basic oxides and hydroxides. Therefore, there is no reaction of two bases. However, aluminium oxide, being an amphoteric oxide, reacts with sodium hydroxide. This produces sodium aluminate. Fe2O3 is left in solid form. Now iron oxide is filtered off. The aluminium oxide is separated from sodium hydroxide. So that is how pure aluminium oxide is formed. Pure aluminium oxide is called alumina. Alumina is electrolyzed in molten form to form aluminium. Alumina has a very high melting point, so a compound called cryolite is added. The function of cryolite is to reduce the melting point of alumina and to dissolve it. Now, once alumina is in molten form, the electrolysis begins. These are the anodes, and this is the cathode. This is molten alumina. Now what happens is that alumina Al2O3 forms ions that are aluminum 3+ and oxide. Electrolysis of these two produces aluminum and oxygen. The equations: anode, oxide ion forms oxygen gas and electrons, while at the cathode aluminum ion forms aluminum. Oxygen, being a gas, moves up as bubbles, and due to the heat present, oxygen reacts with the graphite anodes, forming carbon dioxide. The side equation is carbon plus oxygen producing carbon dioxide. Therefore, the anodes dissolve and have to be replaced periodically. When active electrodes are used at the anode always dissolves, forming ions of the material that the anode is made of. So if the active electrode at the anode is below hydrogen, then at the anode the equation is written using that electrode. For example, if it is copper, or for example if it is silver, so silver will form ions, and in this case at the cathode the same material will be used to form atoms. So Ag+1 plus electrons. This was using an active electrode at the anode which is lower than hydrogen in the reactivity series. Now if the electrode at the anode, active electrode at the anode, was above hydrogen in the reactivity series, for example zinc, so at the anode zinc would dissolve to form zinc 2+ and 2 electrons. However, at the cathode, for the cathode now, there will be 3 ions. One will be Zn2+, one will be H+, and one will be the cation from the electrolyte. For example, if the electrolyte is sodium chloride, so then the third cation would be Na+. Now, so when we're using an active electrode at the anode which is above hydrogen in the reactivity series, at the anode that the material will dissolve, but at the cathode for the cathode, we'll have to use the reactivity series to decide which ion will discharge. So over here, hydrogen will discharge. So at the cathode, H plus electrons produces H2. A simple electrochemical cell is constructed by connecting two metals from the reactivity series using a suitable electrolyte such as HCl or H2SO4. Now, if we have to make a high voltage cell, we have to connect two metals which are furthest apart in the reactivity series. So, for example, for a high voltage cell, we can take magnesium and copper. Electrolyte is sulfuric acid. Now, electrons flow from the more reactive metal to the less reactive metal. So this will be the direction of electron flow. Now in a battery, electrons flow from the negative terminal to the positive terminal. That is why this becomes the negative terminal or the cathode, and this becomes the positive terminal or the anode. In a high voltage cell like this, the bulb shines brightly but only for a little while. Now a low voltage cell is formed when we connect two metals which are close together in the reactivity series, but there should be a difference of at least one metal in between. So for example, if we take zinc and tin, so this would be a low voltage cell. The bulb would shine lightly but for a longer time. In a simple cell, we cannot take potassium, sodium or calcium as the electrodes because they would react very vigorously and dissolve in the electrolyte. Hydrogen oxygen fuel cell. The advantages of an hydrogen oxygen fuel cell are that it is renewable, and it is environment friendly. Disadvantages: it is expensive, however, hydrogen gas is difficult to store because it is combustible. This is the construction of a hydrogen oxygen fuel cell. The electrodes are made of porous graphite to allow gases to pass through, and they are usually coated with nickel or platinum, which acts as a catalyst to speed up the reaction. Electrolyte is usually potassium hydroxide, aqueous, and it is warm to speed up the reaction. At the anode, hydrogen gas enters and it reacts with hydroxide ion to produce water and electrons. So at the anode, hydrogen plus hydroxide produces water plus electrons. To balance this, at the cathode, oxygen gas enters. Oxygen gas reacts with water to form hydroxide ion. So over here, as at the anode, oxidation takes place. So over here, electrons are being lost, and over here electrons are being added. Once again, at the anode, hydrogen gas enters, reacts with hydroxide ion to give water and electrons. At the cathode, oxygen gas enters, reacts with water and electrons to produce hydroxide ion. If instead of potassium hydroxide, sulfuric acid is used as the electrolyte, then at the anode, hydrogen gas forms hydrogen ions and electrons, while at the cathode, oxygen gas reacts with hydrogen ions and electrons to produce water. Now for the hydrogen oxygen fuel cell, hydrogen is obtained by either the steam methane process or by the cracking of alkanes, whereas oxygen is obtained by the fractional distillation of liquefied air.